Thank you very much for that super nice introduction. So let me first of all start off by saying that I'm super excited to be here, first Angular conference in Ukraine. The conference has already been amazing. I've seen some awesome talks, so I hope I can add one to that. So the title of my talk is Keeping Your Memory Safe, and the reason I want to give this talk is because when I was doing code reviews or coaching sessions, and I was telling people like, be careful here, this might introduce a memory leak, I felt that for them it was quite unclear what I was talking about, especially in the context of Rxjs. To kind of test that hypothesis, I went on Stack Overflow and I Googled for the combination of the words Rxjs and memory leaks. And it was pretty easy to find a lot of issues which all had kind of the same problem in them, is that people don't really understood the core concept of Rxjs. So that's why I want to tackle this today and try and give you some insight on how Rxjs works and how it actually can introduce memory leaks, and of course how to avoid them. Another reason I want to do this is because I often hear that people ask, why should I care about this? It works on my machine. Yeah, but we constantly reload our applications. We also have to think about people who are using our applications and don't close them for over a day. Then even the smallest memory leak might make your applications crash. So it's something we want to avoid. Why? As I said, because they can crash. Another reason we want to watch memory leaks is because memory is a pretty scarce thing. On my machine I have 16 gigabytes of memory, so that's perfectly fine. But we also have to think about people who use low-end Android devices. They only have a really small amount of memory, so we have to think about that. So today I want to talk about memory management in JavaScript, what a memory leak is, how it can be introduced by Rxjs, and how we can actually fix that. So that's kind of the topic for today. 2 words about myself. My name is Kwinten. I'm a freelance front-end architect. This is a picture when I used to have hair, which is a while ago, but okay. I'm also from Belgium, so you're welcome for the beers last night. If you have a hangover, you're welcome as well. Those are my kids. As Max already said, I'm a co-founder of a company called Strongbrew. We do trainings around Angular, Rxjs, and NGRX. We also do them at conferences, like you can see in this picture. And we also have a blog with some pretty advanced topics, so definitely check that out. But back to the topic of today. So first of all, to kind of understand what a memory leak is, we need to have some basic understanding on memory management in JavaScript. And the things I'm going to say might be a little specific for the V8 engine, but it should be kind of the same. So in JavaScript, at a really low level, we only have 4 data types. So we have booleans, we have numbers, we have strings, and that's almost it. We also have objects, but we don't, for example, have arrays. Arrays is something that is implemented using an object, where the index of the array is the key in the object, and the value is the value, of course. But those are the only data types. And whenever we define, for example, a boolean, I would say let is user logged in is true, that variable is going to be stored in memory. And the location where it's being stored is called the memory heap. And if we want to visualize the memory heap, you could kind of do it a little bit like this. So by just looking at this, we can already conclude that it's a graph structure. So we have a graph structure that is starting with the red node, and that's really important. In browser environments, the red node is the window object. So all our memory that is living in the heap is somewhat connected to the window object. We also have the green nodes. Those are the booleans, the strings, the numbers, because they can't reference anything else. And in between we have the yellow nodes, and those are like the objects, the array, but even the components, the operators, the observables, and stuff like that. So that is the memory heap. And I said that whenever we use a variable, some memory gets used to store that memory, and that concept is called memory allocation. And memory allocation is something that happens automatically. When we define variables in JavaScript, we don't have to think about, okay, I'm going to store this variable in that location in memory, which is something you actually have to do when you use lower level languages, like for example C++. Then you have to use something like malloc to actually assign memory. We don't have to do that, and that's a huge benefit, because it greatly reduces the cognitive load on us. When we create applications, we have to think about the framework we're using. We have to think about the architecture, we have to think about the functionality. Not having to think about memory allocation is a huge benefit. But of course, if memory gets allocated, it also needs to be freed up. And JavaScript uses something called garbage collection. And garbage collection, so the engine has a garbage collector which runs cycles, and during those cycles it will try and free up memory that is no longer needed. But one thing that's really important about this to know is that garbage collection runs on the main thread, which means that when a garbage collection cycle runs, the execution is stopped. And this is important because now we have an intersection between memory management and performance. Because if we are creating applications which are heavily using the memory a lot, then every cycle will take up a lot of time, and that will kill your performance because the main thread is being blocked. So that's something important to keep in mind. So we defined what is memory, how it is stored, that it happens automatically, that it's freed up, but we did not yet define what is garbage. And garbage revolves around, in theory, in practice it's way more complex, but on a high level it revolves around the concept of reachability. And whenever the engine starts a cycle and he starts traversing the node, every node that's not reachable from the root node, being the window object, that is considered garbage. Keep that in mind for later. A little bit size terminology. We have, for example, the yellow node. The yellow node has something called a shallow size, and this is the amount of memory that this node is keeping itself in memory. And we also have the retained size, and that is the size, so the yellow node has a retained size, and that is the sum of the yellow and the green node. So whenever the yellow node would be garbage and removed, the green one would be removed as well. So the yellow node is keeping the green in memory. So it has a retained size of itself plus all its descendants. Okay, so we kind of have an understanding on memory management in JavaScript. Now what is a memory leak? Quite important. Well, pretty easy definition. Memory which is no longer needed, that is not released. And now you might be a little confused. Because I just said that JavaScript has garbage collection, and now you say, okay, memory that is no longer needed, that is not released. Well, it turns out that it's not an error in the tool, it's an error in the code. Why? Garbage collection uses algorithms to traverse the graph, as I said, or the tree, to find that garbage, but it's our responsibility to make sure that it can be defined as garbage in terms of those algorithms. If we, for example, so it's not the fault, it's your fault. If you have a memory leak, it's your fault, it's not the garbage collector's fault. So for example, when we talk about references, and that's one of the sources of memory leaks. If we want to remove that green node from memory, we need to make sure that there's no reference anymore to the green nodes. Otherwise, it will not be considered garbage by the garbage collector, and it will not be freed up, and that's a memory leak. Same for the yellow nodes. Another thing we can also have references to DOM nodes. If you have a reference to a DOM node, it is also impossible to clean up that memory. So that's something that we have to keep in mind. Luckily, we have this great tool called the developer tools, and my favorite ones are from Chrome. And the Chrome developer tools give us a lot of tools to actually investigate our memory and do some profiling on our application to investigate to see if we have a memory leak, and it can also help us to locate the memory leak. So to kind of show how that works, let me quickly just try and show this for the slide deck. So in our slide deck, we have a few things. So first of all, let me go to the performance tab. And the performance tab is something that's really ideal to give a general idea on how your application works. But what's really nice, and that's something you can do for memory leaks. So now I started to record, and I go around in my application, which are my slides, and I can just stop, and then I can see the memory that is being used. And one thing so at the bottom you can see it here, one thing you need to look for when you're looking for memory leak is we have the blue line, and that is the amount of memory that is being used. And it should always, whenever we switch between, for example, components in Angular as well, it should always go up, but then it should go down. So you should look for that zigzag line, and the beginning and the end should always be kind of at the same level. If it's a zigzag line that goes up, that's a sign that you have a memory leak. So that's one of the tools you can use. Another tool you can use is the memory tab. And inside the memory tab, we can do, for example, something like take a heap snapshot. So I already explained what the heap is. And we can take a snapshot, so let me do that. And what it's doing now is it's putting everything that's in memory, it's visualizing that for us here, and it combines it per category. So we can, for example, see that we have all these objects. We can see that we have in total 6,920 objects, that it has a total shallow size, it has a retained size. We can open that up and take a closer look. We could, for example, search for stuff, which we will do later. So that's something we can use. Another thing we can use, if we switch between the slides again and we take a new heap snapshot, then we can make a comparison, so we can have the drop down here, and we can make a comparison to all the objects that have been allocated between snapshot 1 and snapshot 2. So if you go back and forth between two components, and you can see that many objects are allocated and they are not released, that can also be a source to know that you have introduced a memory leak. One last thing I want to say about this is that we have this garbage icon here. So the garbage collection process is something that happens automatically. You can never trigger manually in code when you want to execute a garbage collection cycle. But when you have the memory tab open, you can do that. So what I can do is, for example, if I go here and I go to my JavaScript instance, I can see that I'm now using, first number is the most important one. I'm almost using 12 megabytes. But if I click this icon, a garbage cycle will run, and then it can drop. So if you move around in your application and you see the memory number going up, but if you click the garbage collection icon and it goes down to the same level, then it's okay. That means that you don't have a memory leak. So that's a really, really quick view into the tools that we have, given to us by the Chrome developer tools. So let's continue to the main topic of today. So Rxjs. Rxjs is my favorite technology. Angular also as well, especially the integration between the two, but I really like Rxjs. It allows you to write a lot of functionality with only a few lines of code, but it also has some downside. It has a pretty steep learning curve, and it can have some unexpected behavior, such as memory leaks, if you don't fully understand how it works. So my favorite definition about Rxjs is one from NgTalks, who's one of the core authors of Rxjs 5, or is in the core team, and he said that Rxjs is programming with asynchronous data streams. And if you know Rxjs, that makes a lot of sense. If you don't know Rxjs, let me try and help you understand this definition. And to do that, let's start with something that everybody knows. We have arrays. And what is an array? An array is a finite data structure which has all these elements in there, and you can apply some operators to it to pull some values out. I said two important things. All the values are already there, and you're pulling values out. Let's translate that to an observable. What is an observable? An observable is kind of the same thing in the sense that it has values, but those values are being delivered over time. So it's asynchronous. Another thing is that when we use observables, we are not pulling out values, but whenever values arrive, those values are being pushed towards us. So that's a big difference. So we have an observable, going back to the definition from NgTalks, where he said that Rxjs is programming with asynchronous. We have asynchronous values coming in. Data, we have data events coming in. Streams. Streams and observable is something you can use interchangeably. So Rxjs is all about programming with asynchronous data streams. To understand how Rxjs can introduce memory leaks, we need to look at the anatomy of an observable. And the anatomy of an observable is something I'll try to visualize using emoticons. It's emoticon-based explanations. So we have, for example, something here. We have an observable, and we can visualize that with a box. Why with a box? Well, an observable is kind of a wrapper around those future values, around those asynchronous values. And one important thing that every observable has is that it encapsulates something. So here we're passing a function to the observable create method, and that function is encapsulated inside of the observable. Really important. Every observable encapsulates a producer function. It is a producer function because it produces events. But just like me on a Sunday morning, that producer function is lazy. It doesn't do anything. It only starts working when we subscribe to it. So whenever we subscribe, we pass in an observer, and at that moment in time, that producer function will start working, and it will start pushing out next events, or completes, or error events. So that's what it's going to push out. So now to my examples. I already saw some people running around with Rick and Morty t-shirts, which I really like. It's one of my favorite TV shows. And in Rick and Morty, there's this one character, and that's called Mr. Meeseeks. And you have a Mr. Meeseeks button, and whenever you click that button, a Mr. Meeseeks appears, and you can ask Mr. Meeseeks a request, and he'll try to fulfill that request for you. And if he succeeds, which he wants to, he dies. Kind of sad, but that's what he wants. But whenever Mr. Meeseeks isn't able to fulfill your request, he might click the button himself to have another Mr. Meeseeks help him fulfill your request. And he clicks it over and over again until it's finished, and then they all die, which is good. So let's try and build a Mr. Meeseeks emulator. And to do that, if you kind of think about it, we could use an observable that emits a value every second. Why? It's like we click the button, we start seeing one Mr. Meeseeks, he clicks it again, we see another one, and so on and so on. So how could we do that? Well, we could use the timer operator. So we have the timer operator, and it will emit an event, so we have that observable that I visualized here. We map that to a Mr. Meeseeks, and we push that into an array. And then in our components, we just loop over that array, and we display a Mr. Meeseeks. So let's take a look at the code. So I have Mr. Meeseeks here. When I click on it, I can click on the button. Mr. Meeseeks appears. Whenever I feel like, okay, he has fulfilled his purpose, I can click the button and I can go away. Let's try and profile this. So I'm going to the memory tab. I'm quickly going to refresh the application because I already introduced the memory leak. So let's say that I click on it, I ask a request, please do something for me. Okay, it's finished. I have another request, let me do it again. Another request, let me do it again. Okay. So now let's take a heap snapshot. And when we take the heap snapshot, what we're going to do is we're going to look for components. And when I look for a component, I can see here that I have a help me Mr. Meeseeks component. And what I also see is that I have 3 instances of it. But that doesn't make sense because I went to the component and I came back, so it should be destroyed. So why is it not destroyed? That's not good. So I actually didn't tell you everything about, so what is happening here? Really important. So we have our timer observable, and what is the timer observable doing? It encapsulates that producer function, and that producer function is using browser APIs to execute an event every X seconds, every 1 second in our case. But that means that we did not clean the reference between the timer and the other node when we were going away from our component. We did not clean up that reference, meaning that the garbage collector was not able to clean up that component, and that made sure that all the other components were kept into memory as well. So it's actually a pretty huge memory leak because I was using an image which was not compressed or anything. So it is a pretty big memory leak. And I didn't tell you everything about the anatomy of an observable. So what I didn't tell you is that whenever we execute this observable, it also sets up something which is called teardown logic. And that's something Tracy already mentioned the first day. So it sets up teardown logic. And whenever we want to dispose of that observable, we can use the subscription to unsubscribe, and that will trigger the teardown logic to be executed. So if we try to fix this and we go to the code, and I'm quickly going to check. Okay, check out version 1. So what I'm changing here is instead of, is this readable? Yes, it's readable. So what I'm doing here now is I'm keeping the subscription at my component level, and in my onDestroy, so we have the lifecycle hook from Angular, in the onDestroy, I'm calling the, where's my onDestroy? Oops, my onDestroy is not here. So in my onDestroy, what I can do is I can use that subscription to clean up the resources from my observable. So I could say this.subscription.unsubscribe. By doing this, so by managing the subscription, I was able to, whatever the producer function did, I don't need to know that, but whatever it did, it set up some teardown logic, and by unsubscribing, I'm executing that teardown logic. So that's really important. Okay. So So we fixed it. So lesson here is clean up observables by unsubscribing. Second thing, first the quiz. Who thinks that this code can introduce a memory leak? What you can see here is that we're subscribing, and we're not managing the subscription. So who thinks that this can cause a memory leak? Who thinks that this cannot cause a memory leak? Well, the majority is actually correct. And the reason for that is that an HTTP observable will also always do one of two things. Either it will have a next event and it will complete, or it will error. And complete and error events are ending events. And at those events, all the teardown logic is being executed as well. So it's not only when we unsubscribe, but it's also on complete and error events. So that's important to know. So let's make our Mr. Meeseeks emulator a little more cool. Let's add another function, and whenever we call that function, so when we're on the page, we click the button to ask a request. We could just stay on the same page and ask, hey, I already have a new request. I don't want to go to the home page again and do it again. So I just want to do it over and over again. So if you look at the code, I can go here, and I can say, I'm going to open the DevTools already. I can say, okay, Mr. Meeseeks, I need your help. Okay, it's okay, but I have something new for you, so I'm doing it again, and again, and again, and again. And when I go back, let me do it another time, so we have some clear data. New request, go back. So now if I go to the memory tab and I take a heap snapshot, we shouldn't be seeing anything, right? We managed the subscription. If you saw on the previous slide, we managed the subscription here. We were taking the subscription and we are unsubscribing on the onDestroy lifecycle hook. So let's see what happens. If I look for components here, we can see that we still have two instances of our Help Me Mr. Meeseeks components. So we have two instances. How can that happen? Well, again, as before, I didn't tell you everything about, so that's weird, right? So I didn't tell you everything. So in the anatomy of an observable, whenever we subscribe, we are executing that producer function. But what I did here was I subscribed again, and I used the same subscription object. But you cannot do that. Why? Because if you subscribe twice, then that producer function is re-executed. So basically what I was doing when I called unsubscribe in my NgOnDestroy lifecycle hook, I was only executing the teardown logic for my last call, for my last subscription. So what we need to remember from this is that every execution needs to be unsubscribed. Not only the first subscription, every subscription needs to be unsubscribed. That's really important as well. So what we did now was we were manually handling those subscriptions. But manually handling subscriptions, it's not something we want to do. That's too verbose. So let's take a look at some subscription strategies. First one is take until. Take until is a pretty known one. So what we can do is we can create a subject, a stop subject, and we can use that subject. Let me make it a little bigger. We can use that subject and we can next the value onto that in the onDestroy lifecycle hook. Then we can use the take until operator. And what does the take until operator do? The take until operator will say, okay, I'm going to listen to this stream, but whenever the stop observable, whenever that one emits a value, I'm going to do two things. I'm going to unsubscribe to the top, and I'm going to complete to the bottom. So this is a way, if you use the take until operator, and you have a lot of subscriptions in your component, you only need to create one subject and use a take until, instead of imperatively having to handle all those subscriptions. So that's a take until. Another quiz time. Who thinks that this cannot introduce a memory leak? Is this a memory leak or not? So what I changed here, we have a combined latest, and that combined latest is combining two streams, a timer stream and a stream that never completes. And inside of our timer stream, we are using the take until operator. Who thinks that this can cause a memory leak? Who thinks that this is okay because we are using take until? Okay. Again, most people have it right. And why is that? Well, you might be like this right now, but if you think about it, what is really happening here, and now we're going pretty deep into how it works, we have an observable, and on that observable we apply the take until operator. and we combine that observable with another observable using the combine latest operator. What is happening at the moment that, so we have some combinations, that's just how combine latest works. Whenever take until emits a value, as I said before, what will it do? It will unsubscribe to the top and it will complete downwards, but combine latest does not pass on complete events until all the observables you are combining have completed. So this stream keeps emitting, and whenever that stream emits, this one will emit as well. So applying the take until operator is not enough. You always have to use the take until operator as the last operator. And that's really important. And this is actually something, it's been mentioned a lot, but on Angular in Depth, Nicholas Jameson has an article specifically about this. It's a really good article. He writes a lot of amazing articles on Rxjs, so definitely check that out. Another approach, of course, we can take as an unsubscription strategy is use the async pipe. And this is really my favorite thing about Angular. The integration is so awesome, and it allows us, so instead of subscribing to our observable, we are just keeping a reference to the observable, and we can use that inside of our template using the async pipe. And what will it do for us? The async pipe will do three things. It will subscribe to the observable, but it will also unsubscribe. So when it unsubscribes, you know that you cannot have a memory leak. If you unsubscribe, you know you are safe. And another thing it does is it will trigger change detection. So I recommend to always try to use the async pipe. Only fall back to manual subscriptions if you think it's becoming too complex and you want to handle something imperatively or something like that. But try to use the async pipe as much as possible. So, some key takeaways from this talk. So remember to check the memory tab of the DevTools. I've shown it, super brief, but it's super easy to do. Play around with it, click around on your application, check if the memory tabs, if the memory usage is a zigzag that is going up, or if it's okay. Unsubscribe to execute the teardown logic. If you unsubscribe, there is no way that you can have a memory leak. Just unsubscribe, and it's really important to try to do that for every subscription, of course, but try to do that using the async pipe as much as possible. Another thing I want to say is that error and complete are end events. So unsubscribing from an HTTP observable is something you can do, but you don't always want to do that. If you want to do an HTTP post to do an update, you don't want to unsubscribe because unsubscribing means that you will kill the network request, which is not something you want to do. So be really careful about that. These are some references from Zog that I use to create mine. Definitely check them out. They're really good on memory management. And that was it, so thank you for having me.